Hello and welcome to my student. Today's lectures we have learned the topic electrochemistry. In this topic, now we are going to discuss Kohlrausch's law. Kohlrausch's law are the name as independent migration of ions law. According to this law, which is important to experimental observations, are shows that when limiting molar conductance values we are measured for different strong electrolyte, and when a series of pair of electrolyte with a common cation and anion, which is observed that they an the increasing the value was observed. But difference between the limiting molar conductance values for the pair of electrolytes like a potassium chloride, sodium chloride, potassium bromide, and sodium bromide, also potassium iodide and sodium iodide, was found to be same, and therefore it is possible to, to calculate the limiting molar conductance for the solution of such electrolyte must be sum of the limiting molar conductance of the cations and anions, right? So two statements was given for the Kohlrausch's law. The first statement is the limiting molar conductance for the solution of an electrolyte must be must be sum of the limiting molar conductance of cation and anion of the electrolyte. Right. Second statement was given by Kohlrausch. The limiting molar conductance of an ion is same in all of its salt solutions. So from these two statements by the Kohlrausch are combined and to get the new law was discovered. So for this graph will shows that the strong electrolyte for various strong electrolyte which measure the limiting molar conductance will series of those electrolytes can obtain the values of limiting molar conductance. And so these two statements, it means the limiting molar conductance of an electrolyte is the sum of the limiting molar conductance of cation and anion of the electrolyte. And second statement was given the limiting molar conductance of an ion is the same in all of its salt solution. So these two statements can combine, and given the Kohlrausch's law are shows that the at infinite solutions at infinite dilution, when all intrinsic effects disappear, each ion migrates independently of its co-ion and contributes a definite values to the total conductance of the electrolyte solutions. By mathematically, the lambda 0 is equal to the lambda 0 plus lambda 0 minus, where these lambda 0 plus and lambda 0 minus, they will represent the limiting molar conductance values of cation and anion respectively. Now we have the applications of Kohlrausch's law. This is a first applications of Kohlrausch's law, that is first application of Kohlrausch's law is the determination of degree of dissociation and dissociation constant of weak electrolyte. Firstly, we have the principles. The determination of degree of dissociation and dissociation constant of weak electrolyte on the basis of their molar conductance is given the concentration they will measure of the extent of dissociation of weak electrolyte. But at infinite dilution, the weak electrolyte will be completely dissociated. Right? This is a very important. At number of times we can dilution or infinite number of dilution, the weak electrolyte also completely dissociated, and therefore limiting molar conductance of weak electrolyte will be measured of its complete dissociation. Hence, the ratio of lambda c to lambda 0 will be equal to degree of dissociation of weak electrolyte, right? So this is alpha is equal to lambda c upon lambda 0 is degree of dissociation, and dissociation constant Ka is equal to lambda square into c upon 1 minus alpha. Now we have seen some procedure. How will you calculate or how will you done the experiment by this limiting molar conductance we can measure. Firstly, the conductance of 0.1 molar KCl solution can be measured using the conductivity cell, right? We are present the conductivity cell. So this by using this conductivity cell measure 0.1 molar KCl solution in the lab. Second point, the solution of weak electrolyte of different concentrations are prepared, right? Weak electrolyte solution like acetic acid can be prepared for different concentrations as like 0.1 molar, 0.01 molar, 0.03 molar, 0.05 molar, same like this. So these solution can be made, and we are measure the conductance for such a different concentrations one by one serially. The next points, from the conductance values of such concentrations, we are obtain the values of limiting molar conductance, that is a lambda 0 for weak electrolyte from the given table. So this is a constant values of limiting molar conductance for various concentrations. Next, from the tables also we are note down the specific conductance of the KCl solution. This is the procedure. Now we are going to calculations. The first points, we can calculate the conductance of KCl to determine cell constant. So by using the values of the specific conductance of KCl and conductance of KCl, we can measure the value of cell constant, right? After measuring the cell constant, we are calculate the specific conductance of different concentration of weak electrolyte, which is made in the second points, right? We are prepare these different concentration like 0.1, 0.2, 0.04, 0.05, such like the concentration we are made, and these concentration solutions using the conductance we can calculate the specific conductance. Therefore, specific conductance such a solution calculated as the conductance upon the cell constant. Next point, the values of specific conductance we are calculate is here. Calculate is here. Also, we can measure the molar conductance of weak electrolyte like lambda c. So molar conductance lambda c is equal to the specific conductance upon capital C. C is the concentration. From these values of lambda c, we can calculate degree of dissociation as like alpha is equal to lambda c upon lambda 0. Now we have see the problems from those calculations. So one of the problem will be given is here the conductance of 100 mole per meter solution of acetic acid was found to be 0.604 into 10 raised to minus 3. Calculate a dissociation constant for acetic acid. Given that the cell constant also given are here 112 per meter and limiting molar conductance of acetic acid also given 391.2 into 10 raised to minus 4 Siemens meter square per mole. So those value also given. Firstly, we know the which values also given. See here in these problems, the conductance also given for acetic acid, right? 0.604. Concentration also given, that is a 100 mole per meter cube. Cell constant given 112 and limiting molar conductance also given 391.2 into 10 raised to minus 4. Right. From this value, firstly we can calculate the value of specific conductance. So specific conductance is equal to conductance into cell constant. So value of conductance is 0.604 into 10 raised to minus 3 into cell constant also given 112. From these calculations of conductance and cell constant, the value of specific conductance is obtained as like 6.765 into 10 raised to minus 2 Siemens per meter. Then we can calculate the molar conductance, right? The molar conductance lambda C is equal to specific conductance upon C is the concentration. So we can calculate is here the specific conductance 6.765 into 10 raised to minus 2 upon 100 is the concentration. From those calculations, the value of molar conductance is obtained as 6.765 into 10 raised to minus 4 Siemens meter square per mole, right? And from these values of molar conductance and specific conductance, we can calculate the values of alpha. Alpha is the degree of dissociation. So degree of dissociation alpha is equal to lambda C upon lambda 0. Lambda C is the molar conductance, lambda 0 is the limiting molar conductance also given for those acetic acid. So molar conductance is 6.765 into 10 raised to minus 4 and limiting molar conductance also given 391.2 into 10 raised to minus 4. For those calculations of lambda C and lambda 0, the values of degree of dissociation alpha is obtained as a 0.01729. Then after the values of alpha, we can calculate the value of dissociation constant Ka is equal to the lambda square into C upon 1 minus alpha. For put these values of alpha, C, we can calculation can be done and the values of dissociation constant is obtained as 3.044 into 10 raised to minus 5 mole per dm cube. So these values from limiting molar conductance, cell constant, concentrations and conductance of that acetic acid, we obtain the values of the molar conductance, degree of dissociation and dissociation constant. Okay. Now next points we are going to discuss the determination of solubility and solubility product of sparingly soluble salt. Now determination of solubility of sparingly soluble salt. To measure the conductance offered by the salt solution will be low. Normally, conductance offered by water is negligible as compared to the conductance offered by the solute. But in case sparingly soluble salt, the contribution by the saturated solution of the salt and that from the water toward conductance may be comparable, and therefore conductance offered by the pure salt is obtained as the difference between the conductance offered by the saturated solution of the salt minus the pure water. But you know that relationship between molar conductance and concentration of the electrolyte can be used for the for the saturated of salt concentration term replaced by the solubility, and hence molar conductance by limiting molar conductance, and limiting molar conductance in place of molar conductance is justified by saturated solution of the sparingly soluble salt. So this procedure can be used for measure this conductance. Firstly, by using the conductivity cell, firstly we are measure the conductance offered by the water till the constant values. Right? Firstly, measure the conductance of the pure water till constant value. Second, prepare the saturated salt solution of a separate solid from the solution. Right? By using or by preparing the saturated solution, measure the conductance for those salt solution. Next, measure the conductance offered by the such a saturated solution of each salt. And next, conductance we are measure 0.1 molar KCl solution by using conductivity cell to calculate the cell constant, right? From calculations, now we have going to here. Firstly, the conductance of KCl solution, calculate the cell constant, right? We are calculate the cell constant from the conductance of KCl, right? Next, using cell constant, we can find out the specific conductance of distilled water as well as saturated salt solutions, as like the specific conductance is equal to the conductance into cell constant. This is the formula. So such calculations we have seen last slide, like specific conductance is equal to conductance into cell constant. And how will you find the cell constant? Cell constants is equal to the specific conductance of KCl solution upon the conductance of KCl solution. So from this conductance of KCl solution, we can find out the cell constant. Now we have find out specific conductance of pure salt solution obtained, which is difference. Specific conductance of pure salt solution is obtained by the difference between the specific conductance of saturated solution and the distilled water. We are measure separately specific conductance of pure water and specific conductance of the saturated solution. We can find out from this formula, that is conductance into cell constant. From this difference of the specific conductance of saturated solution and distilled water, as like K0 is equal to K0 of saturated solution minus K0 of water. Then molar conductance of salt replaced by molar conductance of infinite dilution, right? Molar conductance of salt is replaced by the conductance of infinite dilution, that is the limiting molar conductance is lambda 0, and therefore the specific molar conductance lambda c, which is replaced by limiting molar conductance lambda 0, is equal to the lambda 0 plus plus lambda 0 minus. What is mean by lambda 0 plus and lambda 0 minus? Lambda 0 plus and lambda 0 minus are the conductance of this cation and anions, and therefore we can measure the solubility as capital S is equal to, in bracket, K0 of the salt. K0 means this is the specific conductance of the salt upon their limiting molar conductance, like lambda 0 plus plus lambda 0 minus. For those calculations, we can calculate the solubility product Ksp is equal to x raised to x into y raised to y into capital S plus y. For such types of calculations which is obtained to determine the solubility and solubility product of sparingly soluble salt, right? Thank you.